Today's lesson, we'll be talking about section 1.4, which deals with rational expressions. Here, the topics that we kind of want to review are adding, subtracting, rational kind of expressions. Those are type of expressions that are in fraction form. So I have a numerator and denominator, but your denominators and numerators are going to involve variables. So we kind of wanted to go through so it help you remember how to make common denominators with some of these things. For example 1 here, we want to perform the following operations and then simplify. For letter A, they have 3 over x minus 1 plus x over x plus 2. What they want you to do here is to make a common denominator and put the two fractions together and create one fraction. Okay? So, if I have a denominator of x minus 1 and x plus 2, neither of them are exactly the same. Remember, when you're dealing with binomials as denominators, they need to be exactly the same to be common denominators. Just because they both have an x in common doesn't mean that you just have to add 2 or add 3 to the x minus 1 and make it x plus 2. You can't do that. You have to multiply by something to make them the same. Okay, so here, since they're not exactly the same, so then the 3 over x minus 1 needs an x plus 2 to the denominator. So I'm going to have to multiply by x plus 2 to the top and to the bottom. Okay. For the right fraction, I don't have an x minus 1, so I need to multiply by x minus 1 to make it the same. Okay. So then now, once you do that, you can multiply the numerators by distributing the 3 and the x to their respective binomial. So 3 times x gets you 3x, and 3 times 2 gets you 6. Then the other one, x times x gets you x squared, and x times a negative 1 gets you negative x. Okay? Now your denominators, if you'd like, you can leave them as binomials. You do not have to multiply them. A reason will show up later that I'll explain once we simplify the two, or put the two fractions together, why we would want to leave them at this point. Okay? So then now, you want to put your two fractions together, try to combine like terms. So you get x squared, because there's no like terms with that. 3x and negative x become a positive 2x and plus 6. And then the denominator, x minus 1, x plus 2. Okay, now here what you want to see is if you can factor the numerator a little bit, because it is a trinomial. But in this case, because it's plus plus and the factors are 6, there are no factors of 6 that add up to 2, so therefore you can't simplify this any further. Okay, so then this would be your answer. The nice thing about leaving the denominator as binomials multiplied to each other is if you were able to factor the numerator, then maybe something from the top to the bottom would cancel each other out, and you'd be able to simplify further. In this case, it didn't factor, so we didn't have to do that. Okay, moving on to the next one. Now here, some denominators may have stuff in common, so let's factor this denominator on the left. So x squared minus 1 is a difference of squares, so we get x minus 1 and x plus 1. Okay, now notice that there's 2x plus 1's on the right one, and we got 1 on the left. So they share 1, so you don't need to multiply 2x plus 1's to the left side, since they already share a common one. It just needs another one. So we need to multiply the left by x plus 1 and x plus 1. It's top and bottom, so it makes it 2. The right side, or the 2 over x plus 1 squared, does not have an x minus 1, so it needs to be multiplied by x minus 1 to be the same. Okay, so now multiply your numerators through. So 1 times x plus 1 gives you x plus 1. We can write our denominator as x minus 1 times x plus 1 squared to keep it simple. Here, multiply your 2 through, gets you 2x minus 2. Okay, and the same thing, x minus 1 times x plus 1 squared. Okay, now here I want to add my numerators to each other because my denominator is the same. Remember there's a minus sign here, so I always make this positive and I switch the signs to the numerator on the right so that it's easier to not forget a subtraction sign. So x plus a negative 2x gives me negative x, and then 1 plus 2 gets me 3. So now having that as my numerator, even though I could take a negative out of x and plus 3 to make it x minus 3, it does not cancel with anything in the denominator. Excuse me. It doesn't cancel with anything in the denominator, so therefore that would be my answer as well. But make sure you're always looking to see if you can cancel something out with the denominator from the numerator once you factor, because that will help you simplify down to simplest terms. Okay. Next example. Now here, these are more complicated because they involve multiplication and division of fractions or rational expressions, plus they have compound fractions or complex fractions in them. Okay. So the trick here is to make the numerator and the denominator, if they're not already in one fraction form, to get it there. So this x over y plus 1 needs to be one fraction, and the 1 minus y over x needs to be one fraction. So I need to make common denominator. So remember 1 is just over 1. So the top one, they both need a y to be the same, because 1 times y gets you that. So multiply by y, multiply by y. Other one, we could use our property that we talked about before, cross multiplying and then just multiplying the denominator. So don't forget your negative here. So it's going to go in between the 1 and the y. So let's try this. So x plus y over y. And then here if I cross multiply I get x, and then I get negative y, and that gets me over x. Okay, so that's a quicker way. If you'd like to do it that way, that's fine. Now that I have one fraction in the numerator, one fraction in the denominator, here now I want to do multiplying by the reciprocal because we're dividing by a fraction. So I need to multiply. So, or another way of saying it is keep it. So you keep the top the same. You change it to multiplication instead of division, and then you flip the next one. So keep it, change it, flip it. You might have heard that before. Here, there's nothing that cross cancels, because sometimes it does, but in this case it does not, so we just multiply across. Now you can choose to leave it like this, or you can multiply through if you like to see it that way. Either way is correct. Okay, so because neither of them is more simple than the other one. Okay, so moving on to the next problem. Here, now notice the denominator is just h. It's already complete. It's one thing. Okay, together, so the 1 over a plus h and the minus the 1 over a needs to become one fraction. So here, let's do the same thing, and just to make that easier, I'm going to move that up. So cross multiply and multiply your denominators to each other. So 1 times a gets you a plus h times negative 1 gets you negative a plus h, and then a plus h is multiplied to a for our denominator. Okay. Now here I would distribute my negative through so that I can put like terms together. Notice that a plus a negative a, they cancel each other out. So when I simplify this, I get negative h over a times a plus h, and then that's over h. Okay. Now here, this is still a complex fraction, but h on the denominator is over 1, so I need to multiply by the reciprocal up, just like I said before. So it's like that. And so here now, there's an h and an h. They cross each other out. So you're left with just negative 1 in the numerator. And you have a times a plus h in the denominator. Okay? And so then that would be your answer. Like I said in the previous example, you can multiply a to the a plus h, but you don't have to. Okay? So that's how we deal with rational expressions. Okay? Have fun.